question number 2. So question number 2 again is from chapter 4. So the question is, a plate is exerted, this is the plate, exerted by two forces as shown in figure above. Calculate the magnitude of the third force. So we are going to have another force that needs to be exerted so that the plate is in equilibrium. So I've given you a hint that for the object or for a plate to be in equilibrium, so summation of force is equal to 0. The question asks us to find the third force. So let's say this one, your F1, F2. So we want to find another force, let's say this way. Let's say, for example, to make sure that the plate is balanced. So we want to find F3. So how are we going to solve this class? So we want to find F3. Okay, so to make it simpler or easier, first thing first, class, we have to resolve the force that we need to resolve. So let's say in this case, we need to resolve F2. So we try to make sure every forces to be in X and Y axis. So where to place the forces? So let us assign that this one is F1 and this one is F2. So your F1 is going to be at this position in XY axis. And your F2 is going to be, so make sure the tail is at origin. So you bring your F2, so F2 is going to be here. So this is your F1. So now F1 is exactly in X axis. Okay, so to make it simpler, we put everything in the table. Okay, so in the table we put F1, F2, F3. Okay, F1, F2, F3. So this is for X component, column for X component, column for Y component. So as usual, we have F1X, F1Y. Okay, so F1X is equal to F1, so it is equal to 650 Newton. F1Y is equal to 0. And then we have F2X and F2Y. So for F2X and F2Y, you need to resolve. So F2Y is going to be downward. F2X is going to be to the right. Okay, so this is your angle. So you are going to write down F2X is equal to F2 cos theta. So 700 cos 30. Okay, and the value is 606.2. And for F2Y is going to be, because F2Y is downward, so it's going to be negative 700 sine 30. So you are going to get 350. Okay, so F3, the one that we want to find out, so we need to find out F3X, okay, and F3Y. So how do we find F3X and F3Y? Okay, so just now I said that when the force is balanced, total force in X equal to 0, total force in Y is equal to 0. So the last row here is for total force. So this is for total force X, 0, total force Y, 0. Okay. So to get the value of F3X, it's going to be 0 minus 650 minus 606.2, which is equal to negative 125.6.2, and to get F3Y is 0 minus 350. So it's going to be 350. So your magnitude can be acquired from this equation. Okay, summation of fx squared plus summation of fy squared. So you substitute all the values in. Negative 1256.2 squared plus 350 squared. So at the end you'll get your force, that is force F3 is equal to 1304 Newton.